All right, so today I'll be helping you start these problems, but I'm going to let you, in every case, finish it. But at least I'll help you start it. All right. The first thing you need to get here is the area of a circle isn't just pi r squared. It's a equals pi r squared. I know that seems like a small difference, but one is an equation, one's not. Having an a equals in front makes it an actual equation. Okay, so to have a function, you need something on both sides of that equal sign. All right, so now, they want the area as a function of its radius. When you say as a function of its radius, that means that they want an r in the answer. Does my answer have an r in the answer? Yes, it does. The area this is a function that has an r in it. That's what they mean when they say a function that has of its radius means that the answer just needs an r in it. What does this answer need in it? A d. So now I got to write the same function, which was the right answer for this, now with a d in it. Well, I can't just go a equals pi d squared. It's not right. But I can replace the r with something. What could I replace the r with? A d divided by 2. Or a half of a d. And half of a d is the same exact thing as a d divided by 2. Either way. Okay. Does this have a function that has a d in it? Then it is a function of d. You gotta get used to that language. A function of, now it wants it to be a function of c. That's the hardest one of them all. Well, it still starts with area equals pi r squared, but it can't be an r, and it somehow has to be a c. Well, this one you probably need to bring in a different equation that tells you something about circumference. Do you know a different equation that tells you something about circumference? Does anybody know any formulas that have to do with circumference? See, this is the part where if you didn't know that, then you would be stuck and you'd never get over it. Okay, so I'll help you with that part. Oh, what? Yep. What about 2 pi r? It's not an area thing. Circumference is, what is circumference? 2 pi r. That seems important. All right, you need to finish this deal and figure out what to put in here so that your answer will have a c in it, not an r. All right. And don't feel like you're wasting your time here. You're going to find that your homework is pretty much these questions or ones just like them. Okay? I'll hand it out to you in a bit. All right, moving on. A square of side x inches. Now, strategy on big problems like this, big word problems that have like lots of directions and stuff, is to read it all the way through once to get a perspective on where you're kind of going, and then go back and draw a picture for it. I'm telling you, you can't do these problems without both a picture and a formula. You'll need both. You can't just do it from formulas. You can't just do it from pictures. You need a picture and you need a formula, and then you need to put them together. You'll get at what I'm saying later as we do more and more of these problems. They'll always have a picture. They'll always need formulas. You need both to be able to finish it. All right, so let's get a big picture of what this is. The square of side x inches is cut out of each corner of a 12-inch by 19-inch piece of cardboard. And the sides are folded up to form an open top box. All right, that's a lot. Now let's go back and see. What shape is this piece of cardboard? It's not, nope, it's not a square. It's a rectangle. It's 12 by 19-inch piece of cardboard. And what's the square part? That's the little corners that are getting cut out of it. All right, so now you need to get this picture on the paper. So on your paper right now, would you please draw me a 12 by 19 rectangle? Don't have to measure it or anything. Just say this is 12 and this is 19. And then it's got corners cut out of it, right? So draw me a picture of that. The corner's getting cut out. How big is the corner? It says even what to call it. X. So this is a box. It's a square that I'm cutting out of the corner. So I'm going to cut this corner out right here. That's X. That's X. And it's not just cutting out of one corner, is it? It's cut out of each corner. So then I could go like this. X, X. I could go like this. X, X. And should you do this? Absolutely. You need to have a good picture, or you will not be able to figure this out. Yes. I'm recording again. Okay. So I am going to clean this up so I can see that my corners have been cut out of my box here. All right. Do you guys have that? Now, where you're going to fold it up to make a box, I encourage you to make little dots here, like this. Those are the lines on which you would fold it. All right, now, you have to imagine that you're folding this thing up. Do you get that the sides are no longer 19 long anymore? They're 19 minus something, right? 19 minus not just X, 2X. Very good. All right. I want you to see if you can. Okay, I'm back from that little pause there. I'm going to just replace the length with something, the width with something, and the height with something. And the length of my box would have been 19, but now it's not anymore because it chopped off this part and this part, and those are going to get folded up. So it's 19 minus 2X. My width used to be 12, but now I take off 2X's, so 12 minus 2X. And then my height of my box, this is the weirdest one. How high is the box? It's just X. You see how my volume is now in terms of X? It's just got X's in it. You get that? All right, this kind of problem is really important. Not only is definitely a type of question that could be on the SAT or the ACT test, it's the kind of question that we like, and we're going to be using over and over again. Okay, so make sure you learn how to do this kind. How big should the cutout squares be in order to produce the box of maximum volume? All right. We want this to be a maximum, huh? You know what that looks like on a picture, a maximum? Say the graph was doing this. Can you see a maximum there? How could you get a nice picture for this? Graphing it with a graphing calculator would give you a nice picture, wouldn't it? You'll be able to use calculators for this unit. That's the one good thing about this unit. You don't have answers posted, but at least you can use a calculator whenever you want to. Okay, so would you right now grab your graphing calculator, and just remember, you can type this in right here, and it's going to have 3 X's in it, so it's an X cubed. It's going to be kind of a wavy thing. You can borrow one right there. And yes, you'll probably have to adjust the window on it. It's going to be a little bit of a pain, but once you get it graphed, you'll be able to find the maximum. It's just find, second calculate maximum once you've got the thing graphed. All right, so now I pretty much did that problem beginning to end for you, but I'm hoping that you saw some techniques there. One, big picture thing, you got to draw a picture. You got to label the picture as best you can. Can't just be a picture of a box. It has to be a labeled picture. Then you got to write formulas out like this. All right. One other thing they sometimes will do, they'll like say the volume has got to be 28. Well, if they do that, it's really easy. You graph the 28, you graph this, and you see where they cross. Remember that technique? Graph both sides, see where they cross? Okay, but they aren't telling us that right now, so we must be just wanting to graph just the right side, the one with the X's in it, and see if there's any high spots on that graph. Do you see any high spots? All right, now this brings up an important point. What if there's 2 high spots? Let's talk about what's realistic. What is X again? Go back to the beginning of my picture here. What's x? X is how long I'm going to cut out of this little side of my piece of cardboard, right? Do you get that I can't cut out like a 20-inch corner? Because why? It's only 19 inches long in the first place. This is important. Listen. So, if this has to be less than 19, in fact, like exactly how big can it be? Well, it's got to be cut out of both sides, in fact. So if you think about it, do you get that if I'm going to cut one out there and one out there, and the total was 19, that unless I'm going to cut the entire side of that box out, that it has to be half of 19 would be like the biggest corner I could cut out? How about if I go the other way? Let's go with the 12 because it's a nicer number. Do you get that if I use 6 here and 6 here, that I wouldn't even have a side left? Because the whole side's 12. So if I use 6 and 6, 6 is pretty much the maximum, and that even is too big. So do you get that my domain, or the numbers that would make sense for x, are that if I cut out x is 0, do you get that I'm not cutting out anything? So it can't be 0, and it also can't be 6 because that'd be too big. Do you get that x has to be between 0 and 6 then? That's the domain then for my x, because the most it could be, or the smallest it could be, would be 6. Well, what if I go to the 19 side? Well, if I use that, I could end up with a number that's too big, and it wouldn't work for my 12 side. So my numbers have to be between 0 and 6. So if you get two answers, and one of your answers is like, here is like, something between 0 and 6, and you have another answer later that's even higher, but it's like 10, well, it won't work. Because our maximum we could cut out is 6. We can't even do 6. We got to do less than 6. So if you have two answers, pick the one that actually makes sense in the context of the problem. You don't want to be the kid who says, I want to cut out 25 inches on each corner. It doesn't make any sense. All right, so your graph, when you do it, I hope you see that you have two high spots. There's like a high spot, and then isn't there going up again to like make another high spot? Okay. Well, I know it starts looking like something like that. And your high spot, if it's between 0 and 6, that's what you're looking for. Even if it goes up more later, I don't care, because if it's past 6, it's too big. Have to look at the window. Just mess with your window so you can see your graph. All right, so basically we talked there about finding the right window for your graph is going to be important. All right. Next thing, I want to look over this one. This is going to be a challenge problem for you. It's a different one from the homework. Now remember how I said you should read over the problem, get the big picture, and you also should make a picture, and you also should have one more thing that's not up here. What's that? A formula, yeah. Function is and a formula are the same thing. So you need a formula at some point. So now let's read over the big picture. Grain is leaking through a hole in a storage bin at a constant rate of 8 cubic inches per minute. The grain forms a cone-shaped pile on the ground below. This is like the pile of grain that has been coming out of the hole. So it's been dropping into this pile, and I don't know if you've ever seen that when you drop like sand into a pile, it makes like a cone shape. Okay, and same with grain. Same with dirt. If you have like small, if it's ground up small enough, it'll make like a cone-shaped pile. All right. The grain forms a cone-shaped pile on the ground below. As it grows, the height of the cone always remains equal to its radius. Ooh, that seems important. Height, same as radius. Remember what I said about labeling your picture? Would you please draw yourself a little cone like this? It can just be like draw a circle like this and put a dot at the top, and there's your cone. Okay? All right, so you draw yourself a cone and then label it. Take a second. What's that whole height the same as the radius deal? Maybe you should use X because that goes into a calculator better than an R or an H. And if this distance and this distance are the same, my cone isn't proportionally correct. Let's see if I can stretch my cone. I can't. I'm actually delete him then. I want to delete the whole problem. Undo. Find my. There it is. Okay. I'm going to redraw my cone, except better because that one isn't proportionally correct. I want my radius to be the same as my height, so it's basically a short, fat cone. And that distance is the same as that distance. Do you get you should call them X and X? All right. So what's the whole base of this thing then? It's not X. What's the whole base? New. It's 2X. It'll be twice as wide for the whole base. Okay, now, if the cone is 1 foot tall now, how tall will it be in 1 hour? Ooh. All right, so one thing at a time. We still haven't got a formula in here yet. Does that seem important? Yes, we need a formula. What's a formula that goes with volumes of cones? Do you remember it? You, in the real world, if this was your job and you were asked to figure this out, maybe you work for a company where they got a big pile of stuff that's, you know, piling up, grain, for instance, you just probably Google it and you'd look for the formula for a cone. Okay, I will be your Google, and it's pi r squared because it's got a circle in it. Do you agree it involves the height of the circle? So that's h. And do you remember that that would be a cone, or sorry, that would be a cylinder. That would be like this. And this isn't a cylinder, this is only a part of a cylinder. It's less than that. 1/3, very good. Somebody remembered it. 1/3 pi r squared h. So there's your formula. But wait, they don't want me to have an R and an H in my answer. What do they want in the answer? An X. And what does R in my picture? What is R? X. Someone put an X right there. And what is the height in my picture? X. Do you get how I have just changed it to 1/3 pi x squared x? And what does x squared x mean? X to the third. Yep, x cubed. Do you get I now have a formula where if I just stick in x, it'll tell me the volume? Take a wild guess what I should do with my 1 foot tall then. Plug it in. 1 foot tall means x is 1, except one thing that'd be smart. When I did this first hour, I did it with 1 foot, and I used 1. But then I realized later they use cubic inches. So maybe instead of using 1 foot, I should use 12 inches. I'll save you some time. So if I put in a 12, it's V equals 1/3 pi 12 cubed. And what am I finding? I'm finding the volume. I'll know how much volume is in my cone pile right now by doing that. Now, do you get that it's growing? So whatever this comes out to be, this volume of 1,000 or whatever it is growing by 8 cubic inches per minute. 1 hour will be how many minutes? So all of a sudden you're going to know, okay, I got this much more, and you'll know what the volume is. Right? Then if you put the volume right there, you'll be able to figure out what. You put the volume right here. Do you get there's only one thing left in that equation you could solve for? Say the volume comes out to 1,500. What's left? There's only one thing to solve for. X. You could find X. You could see how tall this thing is by solving. Now, wouldn't it be nice if you could use a calculator? And you can. You could graph this side, graph that side, see where they cross. And what if your answer came out to, 900 inches? You'd make sure that, wait a minute, that doesn't make any sense in the context of the problem. What if your answer came out to -4 inches? That doesn't make any sense. Make sure your answer makes sense, as in its domain makes sense. Your answer needs to come from the domain, or the things that are possible for this problem. So we know that it has to be taller than 12 inches. It already is 12 inches tall. Of course it's got to be taller than 12. And it's got to be less than, well, I don't know, just to be reasonable. It better not be negative, and it better be less. So if it's only growing by 8 cubic inches per minute, it's not going to grow to be like 10 times as big as it is. All right. I've given you a lot of help, but I didn't finish it because it's your homework. You need to finish it. I partially killed the mammoth. All right. So, your last question I want to give you, I want to hand these out to you, and then I'll have you start problem 5 with me. You'll see when you look this over that I've already helped you a fair amount with questions 1, 2, 3, and 4 even. Did you get the... Okay. Let me help you start number 5. A sphere is contained in a cube, and then it says something really mathy. Tangent to all 6 faces. Do you know what tangent actually means? It means touching, basically. Touching in one spot. So all it's saying is it's like a basketball that's inside a box for the basketball, and it actually touches perfectly on all the sides. So it's touching there, it's touching once there, it's touching once there. Get the idea? All right, so basically they're trying to set it up real nice so that the radius of this basketball compared to the length of the bottom of the box, do you get how they'd be related to each other? All right, so now, we're supposed to have a picture and we're supposed to label it as best we can. If we don't know what the radius is, what do you think I should put for it? So put an X there, then what would you put on the bottom of the box? 2X. Very good. How about this side of the box? 2X. Good. And we don't have to label everything, but we've got a lot of things labeled. All right, so first thing, draw a picture, label it as best you can. Did it. What's the next thing I told you to do? Get a formula, some sort of a function. And what's a formula about spheres and boxes, and what is it asked next? The surface area of the cube. Do you know the surface area formula? All right, well, with a cube, it works out really nice. You get the cube has 6 faces, and they're all the same. So it's going to be 6 times something. And then what is the area of one of my faces of my cube? Do you get it? Generally, it's length times width. Okay. And then what is the length? The length of this. 2x. Times the other one. The width. 2x. See what I'm doing here? I just put the picture into a formula. That's the third step. First step, make a picture. Second step, figure out a formula. Third step, put the picture into the formula. Now, don't I have a function that has only x's in it? Yes. And now I can almost done. All right, so what is 2x times 2x, by the way? 4x squared, very good. And then the 6 times that. So 6 times 4x squared. What would that be? Surface area is 24x squared. That seems important. All right. Have I figured out an actual answer yet? No, because they haven't told me any numbers to put into it. All right. But what did they want? They wanted the surface area of the cube as a function of the radius. Does this have the radius? Yeah, I just called it. I could have called it R if I wanted to. So is this a formula that has only one thing in the answer? Yup, and it's, I guess if you wanted to call it R, that would make some sense in the context of the problem, but I usually use X because we usually type it in the calculator and usually use X instead of R. Okay, the last one I want to just set up for you a little bit, number 6. Because a lot of kids don't even know how to start this one, and I'll admit the first time I saw it, I was a little confused. All right, so you got your graph, and it says that there's a triangle on there that's isosceles. Do you know what isosceles means? In case you've forgotten, isosceles are this kind where two sides are equal and one's not. Okay? It's an isosceles triangle on there. And then it says that the corner has to be at the vertex. So basically, do you get that the triangle needs to look something like that? And these have to be the same size? All right. There's a lot more to that problem. It has to do with this corner here being on the edge of a parabola. But I'm not going to finish this for you. I'm going to let you see if you can figure it out. This is one that's more of a challenge. Okay? I don't expect you to know right now. If you knew right now, it wouldn't be a challenge. It might take you 10 minutes of thinking hard to figure out, what did he say again? Okay, I got a picture, but oh, maybe I need a formula. And then once you get the right formula, oh, I got to somehow get the picture into the formula. And then you'll have it. All right. These are going to be a challenge. Now, let me just ask you you need to rise to the occasion and try these. I will totally respect the kid who comes on Monday and even has almost all the problems wrong, but has at least clearly tried, has drawn pictures, has labeled the pictures, has done the best that they could, wrote down some formulas that they thought might apply, and tried. Okay? I will respect that. What I won't respect is, I didn't have any idea what was going on, so I just left it blank. Don't do that. You need to try. You need to lift these weights. They're heavy weights. You're going to get stronger as you lift them. If you just look at the weights, it won't make you stronger. All right. That's all I got for the video for you.